I'm going to start off by talking a little bit about what the hierarchy ID is. Now, as the name suggests, relational databases are best at storing and retrieving relational data. No surprise there. That's the kind of data that fits neatly into multiple tables, each consisting of rows and columns of relatively homogeneous data, all related through mechanisms such as foreign keys. But the reality is that sometimes you have chunks of data that don't fit neatly into the relational model. One example of commonly used non-relational data is hierarchical data. This is data that defines some kind of hierarchy, such as an organizational chart or part subassemblies to build a complex object like an automobile. If the structure is rigidly set with a limited number of levels, you can do a decent job of representing the hierarchy with a table for each level, or other techniques. But it can be very difficult to represent the hierarchy if the structure needs to be flexible. Now, you can always store hierarchical data outside of SQL Server. Over the years, people have come up with various ways of adapting hierarchical data to fit the relational model. And there's really three major ways that people have been doing this for years. The first is through table self-joins. In a table self-join, you use a single table to contain the hierarchical data. The table has a foreign key to itself, thus the name self-join, to reference another row in the table. A good example of this is the Northwind Employees table, if you're familiar with that old sample database. It has a reports to foreign key field to identify the person to whom that employee reports. And then you can use that field to construct the Northwind sales organizational chart. Now, this is a scheme that Entity Framework supports beautifully. So self-joins, no problem with an Entity Framework. Another technique is through XML. XML data is inherently hierarchical. It consists of elements that entirely contain one or more child elements in a structured hierarchy. Way back in SQL Server 2005, Microsoft introduced XML as a native data type, and they integrated it very well with relational data. XML is handy because you have a great deal of flexibility in how you define the hierarchy. But you do have to learn some specialized methods to work with the data, and searching and sorting on the data can be problematic. And any framework will support this, but there are some integration problems, potentially. Kind of depends on how you implement it. And then the third option was people rolled their own. SQL Server 2005 also introduced the capability to create your own custom data types using the .NET Common Language Runtime, or CLR. Many people took advantage of this feature to create their own hierarchical data type, with all the features to support their needs. SQL CLR types support properties and methods, so the type could implement behaviors as well as custom data structures to support hierarchical data. Such custom types were far from trivial to implement, and it took a lot of work to get it right. But over the years then, Microsoft has used this technique in order to implement some of the new data types, including hierarchy ID as well as the spatial data types. So this is something that's built into SQL Server. And a lot of people have rolled their own, and you can even find them available in various online forums. So you can download, and if it's close enough fit, you can adapt it to your needs. But it's still a lot of work to get right and to make work for your particular application. Okay, but because this is such a basic need of databases, a very frequent need, then Microsoft introduced a hierarchy ID data type back in SQL Server 2008. Because again, this is just something that developers and administrators need. They need to store hierarchical data. And a lot of what Microsoft does is when it's looking for new features for products, it looks at custom solutions that users are doing with the product, and they looked out and saw that a lot of people were implementing this kind of a data type. So they added it to the product. So it's been around for a long time now. So what this is a compact object that you can use to manage hierarchical data using materialized paths. It's compact in that it uses very little storage, and it materializes paths and manages the hierarchy for you. And as I mentioned, it is a system CLR type, so it's written with .NET code that's included with SQL Server. Because it's a system type, though, you don't have to enable custom SQL CLR code in a database before using the hierarchy ID data type, as you have to do for your own SQL CLR code. By default, in a fresh install, new instance of SQL Server, the ability to embed .NET assemblies within the instance or within a database is turned off. And that's security by reducing the attack surface. So you have to explicitly turn it on if you want to use that feature. You don't have to worry about that for system data types that Microsoft has implemented, because presumably they're safe. Now, you can use the hierarchy ID type to represent organizational charts, map a file directory system on your hard drive, create an assembly part chart with subassemblies, represent project tasks, and for lots of other uses. In fact, the more you become familiar with the data type, you can get very creative. You'll just start coming up with new ways to use this type. Now, the nice thing about this is because it's a SQL CLR type, it has rich support with methods that provide a lot of ways to maintain the hierarchy, such as letting you make arbitrary insertions and deletions, as well as relocating sections of the hierarchy to other places. So you have a lot of ability to move things around. Now, there is no magic to the hierarchy ID. Although SQL Server gives you everything you need to maintain the integrity of the hierarchy, it doesn't automatically enforce hierarchical relationships. You have to do that in your code using the tools that are part of the data type. The hierarchy ID type also does not guarantee uniqueness, but you can enforce uniqueness in other ways, such as with a unique constraint on a hierarchy ID field that's within a table. So it's a data type within SQL Server, and so you have access to indexes and various other kinds of constraints that you can use. All right, and then just real briefly, there are two different ways to index a hierarchy. The first is depth first, and the second is breadth first. Now, which of these methods you use will determine how SQL Server navigates the hierarchy when searching for or listing nodes in the hierarchy, how the data is stored, and the performance of queries that involve the hierarchical data. And basically the difference between the two is that depth first is that it explores a complete tree of the hierarchy before moving on to another tree. Breadth first is that it checks all siblings before looking at the children of the siblings. So it does one entire level, checks second entire level, third entire level for as deep as you have defined this hierarchy. Okay, so overall, hierarchy ID is a pretty nifty data type that's been around for 3 major versions of SQL Server. It does have some limitations that prevent its use in some scenarios. But if it works for you, it can handle those hierarchical tasks in certain scenarios really pretty well. So Entity Framework supports it, right? Well, let's take a look. Well, I'm sorry to say that support is missing in action. But the thing here is, and the reason why I'm including this here, is that you're going to need to deal with the situation. The problem is that because Entity Framework doesn't support hierarchy ID, when you reverse engineer a model from a database, there are going to be things missing. I'm happy to report that later versions, more recent versions of Entity Framework, have improved upon the situation. But you're going to just need to deal with what happens when you have a database that you're reverse engineering that has hierarchy ID. Okay, so moral of the story is that if you've been using Entity Framework 5, you really had a pretty serious problem. But in Entity Framework 6 and later, the problem is more or less solved. More or less. All right, so here I am in the empty Visual Studio 2013 environment. What I'm going to do is I'm going to create a new ASP.NET MVC application. And I'm going to use this project to show various techniques. But for now, I'm going to create an entity data model and reverse engineer a database that has hierarchy ID fields. All right, so you can see what's happening, and we can talk about some of the issues. All right, so I'll come up here, File, New Project, and I want to create an ASP.NET web application. I'll put it in a convenient location, and I'm going to call this SS Demos. And that fires up this dialog box. Now I could use the MVC application here, but this comes along with a lot of baggage. Amongst other things, it has all the authentication stuff. It also has a lot of sample code, brings in a lot of JavaScript libraries and so forth. Has a lot of baggage that I just don't need for a simple sample application. Nothing relevant to what's going on with Entity Framework. So I'm going to use the empty template here, but I'm going to bring along the support for MVC because I want to create an MVC application. Now, it's important to understand that pretty much everything I show you about Entity Framework and its use with SQL Server is going to apply to any kind of .NET application that you can use Entity Framework with, which is pretty much any kind of application. It's just an MVC application is a convenient way. I'm mostly a web developer when I write code, and so it's just an easy way to show how these features work. And the nice thing is that the MVC team at Microsoft has built in a lot of support for using Entity Framework within the ASP.NET templates. Okay, that's becoming truer and truer with other application types, but there's just far more support within MVC applications at this point in time. Okay, so because I selected empty, I'm not going to get any of the authentication stuff. I'm not going to host this in the cloud. It's going to be a local application in my case, or on a server that I control. All right, I'll click on OK, and Visual Studio will create that empty project. It takes a few moments for it to set up all the folders and so forth, and now we have this project. But there's really very few files in here. We have a web.config, we have something to manage the NuGet packages, which I'll actually be using because I'll need to implement or include Entity Framework, and some empty folders, and there's one route.config, and there's some empty folders, but a few code files here and there. The important thing about an MVC application is that it uses convention over configuration in order to allow MVC to find various elements that it needs to grab as a user makes requests to web pages. And so I now have the project structure to hold all of those elements. All right, so the first thing I need to do is I need to create the model. That's the M in MVC. This is the class or set of classes that I'm going to use within the application to access the data. And it's going to be built using Entity Framework, so it's going to have all the intelligence it needs in order to interface with the backend database. And in this case, I'm going to reverse engineer the AdventureWorks 2012 database. All right, so I'm going to right-click on Models here, and I'm going to select Add and New Item. And it's in the Data folder here, and I want the ADO.NET Entity Data Model. This is the usual way of reverse engineering a database using Entity Framework and using the wizard. All right, so I'm going to call this the AW model, and I'll go ahead and add that, and that fires off the wizard. Now, as usual, I have a lot of different options. I have the Entity Framework Designer. I can do it from the database, and that's the one I'm going to use. I can create an empty Entity Framework Designer, in which case this is what I would use if I'm going to create the model from scratch, either then to map it to an existing database or to create objects within that model, custom objects that I create on the fly in the designer, and then build the database from that. I can also do an empty code first model and then a code first from a database. All right, so code first is just another strategy. In this case, I'm using database first. All right, I don't have any connections in this application yet, so I need to create that connection. So I'm going to go against localhost. I use Windows Authentication. I'm an admin on this machine, so I have access to the local instance of SQL Server, the default instance, which is SQL Server 2014. And then I'm going to select that AdventureWorks 2012 database. And I can test the connection. Everything works. And click on OK. And that creates that connection, and then creates this connection string, and it's going to save the connection string and the connection settings in web.config. And I'm going to just change that name to AW, just make it a little bit shorter, and we're ready to move on. Okay, now here's a problem. My first problem. I'm getting prompted for which version of Entity Framework I want to use. Entity Framework 6.x or Entity Framework 5.0. What's happened here is that the wizard has looked at the version of Entity Framework that is currently installed in the application. Even though I selected an empty project template for the MVC application, I got some references as a part of it. And one of them was Entity Framework. But the problem is that it sees that I'm using a version of Entity Framework, but it sees also that it's not the latest version. So what this dialog box is telling me, and it would explain, if I went to this website, it would explain more. This is a link to MSDN. Is that I'm not using the latest version, and so it's just confirming what version I want to use. So in this case, what I'm going to do is I'm going to cancel out of this because I need to install Entity Framework. Now, if we look at references here, you see it's not actually installed, at least it's not visible within the references there. All right, so in order to do that, I'm going to come down here to the NuGet Package Manager console, and I'm going to install it using Install Package. I can hit the Tab button, and it'll fill out the rest of that. Okay, and then select Entity Framework. Entity Framework, and hit Tab again. And you can see there's an Entity Faker test framework, but I actually want Entity Framework. Hit Enter, and I'll hit Enter again. And it'll go out, reach across the internet, grab that package, and install it in this project. Now, I'm using the Package Manager console that is for just a specific project, but there's also a version of the console that you can use for the solution. So if I come up here to Tools and come into the NuGet Package Manager, there's also this one for Manage NuGet Packages for Solution. So this gives you a different interface that would allow me to install Entity Framework or other packages, do anything within NuGet pretty much, for all of the projects within the solution. I just have one in this project, so the regular console works just fine. Okay, as you can see, as I'm talking today, latest version is Entity Framework 6.1.2, and it's downloaded and installed, and everything is good. Okay, so now I'm using the current version. So let's go back now and unpin that, or actually unpin it, and try to add that model again. And you can see we now have explicitly Entity Framework, and this is the latest version. Okay, so right-click on Models, Add, New Item. That, fortunately, didn't save my setting here. That's okay. And click on Add, and that fires off the wizard again. Okay, so notice I didn't get a dialog box asking me which version of Entity Framework I wanted to use, because it sees that I'm now using the latest version. So that's the reason why you get that dialog box that I showed you. Okay. Oh, and actually the dialog box came a little bit later. All right, so I already created that connection to the AdventureWorks 2012 database, same connection string. I'm going to change this to the AW entities, and move on. Okay, so now there we didn't get the dialog box. Now in this case, I want everything from soup to nuts. So I'm going to include all of the tables, including some tables in the DBO schema that are basically database versioning and logging tables. So I'm going to include those. I'm going to include everything in all of the different schemas. If you've done anything with the AdventureWorks 2012 database, you know there's a lot of different tables. It's a highly normalized database. I'm going to include all of the views, and I'm going to include all of the stored procedures and functions, including those in DBO, and there's a few in human resources. Okay, so the nice thing about this is that for several versions of Entity Framework, it does a lot of work. It has some options, but it does a lot of the work of including all of these database objects. And in particular, it's going to automatically import the selected stored procedures and functions into the entity model. In earlier versions of Entity Framework, you had to import them, but then you had to connect them. You essentially had to take an additional step within the designer before you could use them in your code. Now, Entity Framework 6, I think that was new with Entity Framework 5 or 6, I forget. Now it will do all of those steps for you. So it'll create some complex types that support the return types from stored procedures and functions and so forth. All right, also going to simplify the model namespace. So AW model, and ready to finish, and it'll go out and retrieve, essentially reverse engineering the schema of that database and retrieve all of the objects that I specified. And AdventureWorks 2012 is a fairly large database, and so it's going to take a few moments to do this. Okay, and so we end up with this model. Now, we did get some errors. If you scroll down, there's really nothing fatal here, and a lot of them have to do with the hierarchy ID. So this is a problem here, but I'm going to talk a little bit more about that a little bit later. First, I just want to take a quick look at the model. Okay, so here we have the model. We have all the different objects. AW build version, that's a versioning table. Database log, error log. Here's a view. Views aren't connected to any relationships to any other tables or objects in the database. And then we have things like business entity and person and another view and illustration and culture and product models and so forth. So we have this fairly complex model. If I click on the icon, icon right down there, that's a small little picture that lets you navigate around that structure, but it shows just how many objects there are. Okay, and the nice thing is that you can come over here to Model Browser and navigate around all the different objects. So this is a real quick and easy way to get to different objects in an alphabetical list, because finding, say, the credit card object would be a nightmare if you had to scroll around this database. And AdventureWorks is a fairly complex database, but you can have way more tables than AdventureWorks has as well. Unfortunately, Entity Frameworks now allows you to, the designer lets you partition those so you can have functional areas into different model views in the designer. So that's another feature of Entity Framework that's really cool, that makes it easier to work with large databases. All right, one thing that's a big difference here with Entity Framework 6.anything over Entity Framework 5 is that if I were doing this in Entity Framework 5, I would not have gotten anything in this model. The reason I wouldn't have gotten anything is because of these errors, and specifically these first two errors. Really what the root problem is that the document table implements the hierarchy ID type, and Entity Framework doesn't support the hierarchy ID type. So that's what all of these warnings are about. In Entity Framework 5, I wouldn't have gotten any model at all. The designer would have been empty. I could have looked at the XML. It'd be trivially simple because there was nothing there. It choked. But the reason it choked, not directly because hierarchy ID, this type in a couple tables, wasn't found, but more specifically, the direct cause was that it couldn't find a relationship. So it couldn't create a relationship based on that document table that has that hierarchy ID type. And so Entity Framework 5 wouldn't create the model at all. So now instead what it does is it gives me these errors. The model is completely compilable. I can compile the model, but it's giving me this red error to indicate that I'm not getting something that I probably expected that I was going to get, this relationship between a couple tables. Okay, so that's the problem. Nice thing about starting with Entity Framework 6, I'm pretty sure it was 6.0, Microsoft just ignores that error, generates the model that it can, but doesn't include that hierarchy ID type in the couple tables where it appears within the data type. So this is the thing you need to be aware of. At least you get the model, but it doesn't include all of the objects. So the moral of the story here is that pay attention to your errors when you generate the model. A lot of times you can ignore them, as I'm going to for the purpose of this application, because the application doesn't directly use that table or specifically those hierarchy ID fields, but you may not be so lucky. Okay, so now what I want to do is look specifically at the product document. So I'm going to come over here to Model Browser and scroll down to Product Document. So there you can see that the structure that Entity Framework created. So now I'm going to start up Management Studio and connect to my local instance of SQL Server 2014. I'm going to connect to the database engine. I'll go to the local host and I'll connect. And I'll go down into the databases, AdventureWorks 2012 tables, and this is in production, and Go to Product Document. And I'll open this up in the Designer. Okay, so here you can see that the document node is hierarchy ID. But if I go back to my model for product document, I'll widen this a bit. Okay, product document. Notice the document node doesn't appear. So what the wizard did is that it saw, oh, that's a data type I don't know anything about, so I'm just going to leave it off. But the problem as far as the overall model goes, and the reason I got those red errors, was because that destroyed the ability of this table to have some sort of relationship. Apparently document node is one end of a relationship. Okay, so that's the problem with generating that model. Okay, and just to kind of complete the picture, if I come back over here and go to the human resources .employee table and design that, notice that it too has a hierarchy ID field right there. And if I go to employee in the model, again using model browser, you can see, once again, that was called organization node. You can see that we didn't get an organization node. So it was left out of that table as well. So, Entity Framework, rather unceremoniously, dropped a type when it encountered it that it doesn't support. And what's really weird here is that, again, hierarchy ID was implemented in SQL Server 2008, a lot of years ago. 3 major versions of SQL Server have come and gone, numerous Entity Framework versions, and it still doesn't support it. So I don't know if Microsoft just doesn't have faith in the type, it certainly has some problems, or if the Entity Framework team is just having too many problems implementing it in its current version. It's definitely a feature of SQL Server that needs an overhaul. So hopefully we'll see that at some point. But in any event, at least you do get these errors. And this is the reason why you need to look at the errors when you generate a model, when you reverse engineer a model, when you create a database from a model. You need to pay attention to your errors. Okay, and so solution, you can just ignore it, not use that table or that field. You could exclude that table entirely, which if you're not going to use it in the application, you should be doing anyway to keep your model as simple as possible and so forth. But at least now in any framework 6 and later, we get results. Okay, so I'm going to save this project because I'm going to continue to use this.